Hello students, welcome to Akshar IT Foundation classes and I am your chemistry faculty S. Mohan. Students, in the previous class we started the classification of matter, right? Did you remember classification of matter? Right. So just 2 minutes once we revise about the classification of matter. Chalo, come on, tell what is meant by the matter. What is matter? Good. So matter is anything that has mass and occupy the space, right? Okay, good. How the matter is classified? Yes, based on the chemical composition, physical state, they are classified into solids, liquids and gases. Based on the chemical composition, come on, very good, pure substances and mixtures. Again, pure substances are classified into elements and compounds, right? Elements, how many elements are there? As on today, 118 elements are there. So these 118 elements again classified into 4 types. What are they? Metals, non-metals, metalloids and noble gases, right? So this we discussed in the last class, and we also discussed what are the metals and what are the properties of metals, metalloids and everything, right? So if you see here, these are the examples for some metals. So classification of elements here: metals, non-metals, metalloids and noble gases. What are the metals? Metals are sonorous. Yes, means what it produces sound. The malleable, the ductile, the good conductors of heat and electricity. Generally they are solid, they are hard, they have high melting and boiling point. So these are the metals, right? And of course there are some exceptions also there. For example, you see here mercury and gallium are liquid state. Just now I told you that metals exist in normally solid state, but see here mercury and gallium at room temperature they exist in liquids, and zinc is not malleable and ductile at room temperature, and sodium, potassium they can easily cut with the knife, so they are soft. Some exceptions, right? Then some of the list of metals, I said you to read these elements and symbols, and some element symbols are given based on their Latin names. So I have to remember those symbols, like example sodium, calcium, okay, iron, copper. So these are examples, right? And then we discuss about the non-metals. Non-metals means what? Where the properties which are not lustrous, which are not good conductors of heat and electricity, which have low melting and boiling points, they are called as non-metals. And there are also some exceptions are there, like generally non-metals are bad conductors, means they are poor conductors. But here graphite, which is a allotropic form of carbon, is a good conductor. And allotropic form of another carbon is what? A diamond, and that's very hard, right? So this you can see, and here some of the elements for the non-metal, this also we discussed. Then come to the metalloids. Metalloids means what? Which have both metallic and non-metallic nature, so they are called as metalloids. And best example of silicon and germanium. So you can see elements which exhibit some properties of metals and some properties of non-metals are called metalloids. Example: boron, silicon, germanium. These all are examples, right? Then come to the noble gases, the gases which are present very rarely, okay, very small amounts of in the atmosphere, in the air. So such gas are called noble gases, and these are also called rare gases. And you know these are what are they? Helium, neon, krypton, xenon, radon. Okay, helium, neon, argon, krypton, xenon, and radon. So students, so till here we learnt, and today let us see about the compounds and how to write the formulas of the compounds. Chalo students, so see a compound. What are compounds? Here molecules made up of different elements, atoms of different elements are called compounds, right? Example for compound is water. What is the formula of water? H2O, very good, H2O. So here what are the elements are there? Hydrogen and oxygen. Whether these both are identical? No, hydrogen is different element, oxygen is different elements. So these different elements are combining to form the water, right? Similarly, you can take the sodium chloride, sodium and chlorine. Sodium is a metal, chlorine is a non-metal. These both are combining and forming the sodium chloride. So two different atoms or two different elements, right? So similarly, carbon dioxide, carbon when burned in oxygen, so a carbon reacting with oxygen and forming the carbon dioxide. So these are the compounds, and of course compounds also pure substances because they are made up of one kind of substances, right? So that is it. Now formula of compounds. See students here, to learn the formula of compounds, here first you should know the element names. First you should know the element names. Then how to make a formula, that depends on the valencies that we discuss in the next class. But what compound indicates and how to name it, let's discuss first. Say students here, for example, okay. So students here now, compound. Compound means what? Which is made up of two different elements are called compounds. Which are made up of identical atoms are called elements. Which are made up of identical atoms are called elements. Which are made up of different elements are called compounds, right? So carbon dioxide, for example, I said you that carbon dioxide, right? So here carbon and di means two, oxide means oxygen. So here CO2. So here two different elements are there. One is carbon and second one is oxygen. Then you come to the sodium chloride. Okay. Sodium chloride is what? NaCl. So sodium, Na, this is a metal, chlorine is a gas, that's a other element. So two different elements are combining to form the sodium chloride. Okay. So like this. Now here you see students how to represent the elements and compounds and formula. Say for example, if I write carbon dioxide in the form of carbon dioxide, how it forms. Let's see here, carbon burns in oxygen to form carbon dioxide, you know that. So here carbon plus oxygen gives rise to carbon dioxide, right? Now your symbol of carbon is a C. Symbol of carbon is what? C. And oxygen, generally oxygen symbol is O, but while writing the chemical reactions or chemical equations, we don't write just O, right? We write O2. What we write? O2. Why we write O2? Because oxygen is unstable. Oxygen atom is what? In atomic form, it is unstable. So this oxygen will combine with the other atom to attain the stability and form oxygen gas, right? So whenever you find the oxygen, you know that in the atmosphere almost 21% of oxygen is there. So this oxygen, how we get in the nature? In the nature we get in the form of O2. Even though oxygen symbol is O, means single atom of oxygen is O, but when you write the molecular formula of oxygen, you have to write O2. You have to write what? O2. Why? Because oxygen in the nature it is available in the form of O2 only, right? So O2, then it gives rise to carbon, so C, dioxide. Di means what? Two oxygens, right? Now what it represents? So here C represents that one atom of carbon, one atom of carbon, right? Now it is reacting with O2. So O2 means what? We can write in two ways. Okay, we can say in two ways. One, carbon is reacting with one molecule of oxygen. Okay, so O2 is considered as one molecule of oxygen, or we can say that two atoms of oxygen. Okay, so it's combining with the two atoms of oxygen. Okay, to form this total is called carbon dioxide, and before this no number is there. So we can say that one, okay, molecule of carbon dioxide, one molecule of carbon dioxide, right? So here no number is there. When there is no number, it represents one carbon. It represents one carbon. If I write like copper, for example, I'll write copper. So here Cu means there is one carbon. You have to imagine that there is one number, that is one carbon. If it is two or more are there, then we can write 2, 3 and so on, right? Now for example, I'll give one more example to you, like okay, so here you see water. You know what is the formula of water? H2O, right? So here water is formed when hydrogen burns in oxygen. Hydrogen burns in oxygen. So what is the hydrogen? How can I write now? See here. First I'll write the word equation. Okay, hydrogen gas burn in oxygen, means with oxygen, and form water. This I'll write. Now if you want to write the chemical equation, equation means what? Just by using the symbol. Short form, okay, representation of a chemical reaction in short form by using symbols and formulae. So this is called as a chemical equation. So hydrogen, what do you write hydrogen? Can you write H? No, this is wrong. So whenever you write the reaction in the form of equation, here you would write H2. What do you write? H2. And then oxygen. So oxygen also don't write O, just now I told you that O2, right? Now it gives rise to water, H2O, right? So here how many hydrogens are there? See, 2 is there. So the meaning is what? 2 atoms of hydrogen is this one. Then what is here? 2 atoms of oxygen. This is hydrogen, this is oxygen, right? But here, so this is not correct equation. We need to balance. So after balancing, actually what it becomes is, this is our correct equation. Okay, this is our correct equation. So 2H2 plus O2 gives rise to 2H2O. So balancing we discuss in the later classes one by one. So this is, so here this represents that. Okay, previously okay, so it represents that 2 atoms of hydrogen, right students? So students, here you need to remember one important thing. What is important thing is that generally when the metals are there, generally metals, even non-metals like solids are there, when then we can write their symbols as it is. Like, you know, if you want to write metals, first let us take the metals. Can you give some examples for metals? Iron. Okay. So what you write the symbol for iron is Fe, right? And for example, you want to write the symbol for copper, okay, Cu. Wherever you want to write the copper, then you can write the Cu. Wherever you want to write the say some elements, zinc, okay. So we write zinc. If you want to write silver, so we can write silver. So here when we write Fe, the meaning is what? There is one iron atom is there. When you write Cu, there is one atom of copper. When you write Zn, there is one atom of zinc. When you write Ag, there is one atom of silver. If you put sometimes during the balancing of equations, we write like this also, 2Fe. So meaning is what? The 2 iron atoms. Okay, for example, sometimes if you write 3Cu, for example, if you write like this, there are 3 atoms of copper. Okay, so like 4 Zn is anything. So there are 4 atoms of zinc. Generally, these are the metals, right? Now in non-metals, mostly non-metals, they are in solid state. They also we write like you know what? Carbon. Okay, carbon is non-metal. So wherever you write the carbon, you just write a C. Wherever sulfur, you can write S. And okay, and wherever like phosphorus, generally we write P4. Okay, now but we take here phosphorus as P only. I'll explain that molecule formula. So like you can write carbon, sulfur, boron, we write boron. Okay, So like this we write. So like this, so carbon here nothing is a number, means what? One atom of carbon, one atom of carbon. If we write 2 here, 2 atoms of sulfur. If you write 3 boron, okay, 3 atoms of boron, right? But students here, for most of the gaseous elements, except the noble gases, noble gases, what we write? Directly we write helium, neon, argon, krypton, their symbol you can write. But whenever you write apart other than the noble gases, like oxygen, students, very important point what I am telling here. Whenever you have to write the oxygen in chemical reactions or chemical equations, you need to write to O2, not O. Remember, wherever you need to write oxygen, you have to write what? O2, not O. Similarly, nitrogen. Next, hydrogen. Next, fluorine. Chlorine. Bromine. Iodine. Okay, wherever you need to write these all things, then you know that nitrogen symbol is O, but whenever you are writing nitrogen in the chemical equations, you have to write N2, right? Now hydrogen, whenever you write the hydrogen, then you need to write H2, fluorine F2, chlorine Cl2, bromine Br2, iodine I2. So these all are diatomic molecules. What are they? Diatomic molecules. Di means what? 2. Di means what? 2. So 2 atoms are combining and forming the molecule. Okay. So that's what these all are called diatomic molecules. So remember that wherever you write, okay, these elements, carbon reacting with oxygen to form carbon dioxide. There, when you write oxygen, you have to write O2, right? When nitrogen react with the hydrogen to form ammonia, it will come in the future classes. Hydrogen react with the nitrogen to form, okay, hydrogen, so directly I am writing. So nitrogen react with hydrogen to form ammonia. For this, we write nitrogen in the place of N2. Hydrogen, we write H2, but to balance equation, we can write ammonia formula is NH3. So we can write 3 here, we can write 2 here. So it represents that, okay, 1 molecule of nitrogen and 3 molecules of hydrogen. 1 molecule of hydrogen react with 3 molecules of hydrogens to form 2 molecules of ammonia. Clear to you? 1 here, because no number is there. No number means what? 1. 1 molecule of nitrogen combines with 3 molecules of hydrogen and it forms 2 molecules of ammonia. If you go into some depth, then we can say that 1 mole of nitrogen, if you go to some depth, okay, so slowly we'll learn. So if you go into some depth, then we can say that 1 mole of nitrogen react with 3 moles of hydrogen to form 2 moles of ammonia. Okay, so mole concept is not there, means it now I'm not explaining. So mole is nothing but it's a SI unit to measure the chemical substances. Mole is what? It's a SI unit to measure the chemical substances. Okay, so SI units, you know, no? Like meter can be, means distance is measured in meters, like time is measured in seconds. Okay, so like this, the SI unit of chemical substances, means in the chemistry, generally we use the mole, that is the SI unit. So there are 7 fundamental SI units are there that we discuss later. There are 7 fundamental, okay, physical quantities are there, and there are 7 fundamental physical quantities. The quantity of matter or the amount of matter, that is also one of the fundamental physical quantity, and its SI unit is a mole. Right, students? So here that is about this one. Now let's come to the, yeah. So okay, so with this I think we completed this topic. Now once go through the So this is a symbolic representation. So now what all I explained you. So this is there in this. Once you can see in your material. So and read this one. So you can complete that one. Now here some list of important compounds are there. Some list of important compounds. These important compounds also you have to learn. Hydrochloric acid or hydrogen chloride. So if you see here hydrogen HCl is a chlorine. Whenever an element which is formed from only two elements, so here it is chlorine is there, it is called as a chloride. Instead of chlorine, we should call it as what? A chloride, right? Now, for example, you see this one. Next, for example, you see like so many things are there. Magnesium nitride. When magnesium is reacting with a nitrogen, you think, then it forms a compound called magnesium nitride. Okay, so because only two elements are there, magnesium, nitrogen. When magnesium reacts with a nitrogen and it forms a compound, the compound name is magnesium nitride. Ide should come. Right, remember this, these are very important. So I'll show that, I'll explain you. So here you see some elements, binary compounds, means what are the elements, the compounds that are made from only two elements. For example, see if it is magnesium is reacting with the nitrogen to form one compound called Mg3N2. Okay, what is the name of this one is first element, don't change the name. The name of the first element to keep as it is, that is what? Magnesium. So write magnesium only. Okay, but it's combining with what? A nitrogen. Now while naming it, don't call it as a nitrogen, but you say it as a nitride. Okay, so this is a nitride. Nitrogen becomes nitride. Okay, last it ends with ide. Now similarly, you see calcium is reacting with the oxygen. You think calcium reacting with the oxygen. So it forms a compound CaO. So here only two elements are there. Ca means calcium and oxygen. Now what you can call it as? Not calcium oxygen. Then what you call? Calcium oxide. Okay, this is calcium. Don't change the first one name. So that write calcium. Here oxygen. This is oxygen, but you don't write here oxygen. You have to write oxide. Clear? Now hydrogen is react with chlorine and forming HCl. Then what's the name? Come on, you tell now. What's the name? Very good. So that is hydrogen. Chlorine is there. What should I call? Chloride. Very good. Chloride. Clear? Now for example, Ki is there. Now what's the name of this one? K is what? Potassium. Very good. Potassium. What is I for? Iodine. So Ki becomes what now? First name should not change. So that is potassium remains same. Okay. Now iodine. What I should call right there? Iodide. What it's called? Iodide. So magnesium with nitrogen gives magnesium nitride. Calcium with oxygen gives calcium oxide. Hydrogen combined with chlorine to form hydrogen chloride. And potassium iodide. Okay. So last what will become? IDE. Remember. So this is only for binary compound students. So when only two elements are combining, for that only this will use. For example, if here instead of nitrogen, if there is NO3, you think that it's not called as a nitrate, it's called a nitrate. It's called what? A nitrate. This I will explain you later. Don't worry. So one by one, slowly we go. Okay. Chalo. So here you see now hydrogen chloride. So hydrochloric acid is also called hydrochloric acid, or you can call it as a hydrogen chloride. So this is nitric acid. This is sulfuric acid. So these three are the acids. These three are what? Acids. So see here acids. And say these are the bases. For bases easily you can recognize, like OH is there. See here. Hydroxide. OH is called hydroxide. Na is sodium and OH is called hydroxide. Sodium hydroxide. Next this is calcium. So Ca, calcium. OH is for hydroxide, calcium hydroxide. And this is washing soda, sodium carbonate decahydrate actually. but we can simply call it as a sodium carbonate. So it is 10 H2O. H2O is water. Okay. So in the chemical compounds, if water is there, they are called hydrate. Okay, hydrated salt. These are the hydrated salt. So that we can see later. Now this is calcium carbonate and sodium bicarbonate or sodium hydrogen carbonate. See here, ferrous, here only two elements are there, ferrous and sulfur. Then what you call this ferrous? You don't change the name of that one, first number. But what is the next one? S, sulfur. So what you say? Sulfide. Just now I told you, no? Sulfide, ferrous sulfide. And here sodium, second one is chlorine. Only two elements are there. Chlorine, sodium only. Chlorine, chloride. Okay, chloride, right? So potassium nitrate, aluminum, again here. Aluminum and chlorine, no other element is there. Aluminum only, chlorine should called as a chloride, right? So these are some example. And here some important formulas of gaseous compounds. So carbon dioxide, you know, carbon dioxide CO2, sulfur dioxide SO2, methane, carbon monoxide. See, mono stands for 1, di stands for 2. If carbon only one oxygen is there, mono, carbon monoxide. If two are there, dioxide, carbon dioxide, sulfur dioxide. If two are there, dioxide. So you reckon nitrogen dioxide, two oxygens are there, dioxide. If three are there, tri. So trioxide, sulfur trioxide. Tri means what? Three. Yes, in the mathematics you might have studied, no? What is that? Triangle. What is the triangle? Triangle. Three angles. Triangle. Okay. So triangle. Tri means for triangle. And this is water, you know, H2O. And here some metallic oxides are there. So here see magnesium and oxygen. That's called magnesium oxide. And zinc plus oxygen, zinc oxide. Lead plus oxygen, lead oxide. Mercury plus oxygen, mercuric oxide. Calcium oxide. All oxygens are there, but it should call it as an oxide. Okay. So that is it. So these all compounds of the students here. Sulfur called sulfide. Sulfur, if only sulfur is there, sulfide, right? So magnesium sulfide, Zn zinc sulfide, lead sulfide, mercury sulfide, calcium sulfide, iron sulfide and copper sulfide. Okay, so these are the sulfides, right? So that's all students for today. So here there are some exercises are there. So this exercise you have to do, and if you want me to do, I'll also do. Okay, you can also do. Now the time, okay, only 5 minutes is left for our class. So hope you can do all these things. It's a very simple exercise, very simple exercise. So this you can do, right? If you have any doubts, I'll explain you. So see here, the substances which cannot be broken into any other substances by any physical or chemical properties are called elements. Elements only we cannot break. Compounds you can break. For example, water is a compound. Water by electrolysis, means by passing electricity, we can break them into hydrogen and oxygen. We can break them, but elements we cannot break, right? Elements. So this all is the synopsis are there. So read the synopsis. The symbol of potassium. What is the symbol of potassium? P. Correct? Huh? No. Symbol of potassium is what? K. Because it's taken on the after the Latin name, right? K. What is P then? P is a phosphorus. P is what? Phosphorus, right? Now the symbol of tungsten. What is the tungsten? Tungsten is W, wolfram. Okay. So that is also you need to learn. And next you see a metals or ductile, not ductile, non-malleable, bad conductors. So which is the right answer? Metals are ductile, malleable, good conductors. So your answer is only one, that is ductile. Ductile is the answer. The Latin name of potassium, just how I told you that. Potassium symbol is K. Now what is the Latin name? See a K. Kalium. Kalium is the Latin name of potassium, right? Which of the following is a non-metal? So see a iron, is it? Calcium, nitrogen, aluminum. Very simple. Nitrogen, because nitrogen is a gas, it's not a metal. Okay. Next, elements which exhibit some properties of metal, some properties of non-metals. What is that? It is not a metal, not a non-metal. Some properties of metals, some properties of non-metals. What is that? Metalloids. Metalloids. Next, the chemical formula of sulfur dioxide. Sulfur dioxide. Sulfur is 1, Di stands for 2 oxygens. Sulfur symbol is S, and dioxide means what? 2 oxygens. So SO2, where is that? Yes, this is SO2. Which of the following is a metallic oxide? Metallic oxide means what? Metal with oxygen. So metal here, which is metal ka, where is that? This. Zinc is a metal, magnesium is a metal. Okay, these two are metals are there. But what they are telling here, magnesium, metallic oxide. Here oxide is there, but it is sulfide. Okay, so the answer is zinc oxide. The formula of magnesium sulfide. What is the symbol of magnesium? Mg. Where is Mg? Only one. Sulfide, sulfur. MgS. This is the right answer. Right, friends? Okay, so today I have done 10. So many things are there, and all this is very, very simple questions are there. So hope you can do it. First read okay, synopsis. After that practice. So you will complete, right? If you don't complete, I am there. Don't worry. I'll explain you. Maximum, I think you can do it. So that in the next class, I am going to for the next topic. That is next synopsis, second synopsis. I'll go. Okay. So meanwhile, you practice this one. Practice this one. Okay. And we'll go to the your answers also there. Key is there for you. Once you check with your key is there. Okay. You do it, but without seeing the key. And then after doing, you can check with your answers. Okay. First you do. If your answers are there in your material, first you do. Read the synopsis, then first do the answers, and after that you check your answers. If you have any doubt, you can just post in the chat box. This is a question, we have a doubt, I will explain you, right? Otherwise, then we go to the ancient views of atom. From here, actual subject will start. Now, till now what I explained, that is only like basics, okay? Chalo students, the time is up, only 1 minute is there, okay? Shall we stop now? Okay then, bye.